Yeah, welcome back again. Now we want to look at another uh, test on parametric. We call it a Mann-Whitney U-test. All right, Mann-Whitney U-test. This is a parametric test. Okay, I mean non-parametric test. Sorry, non-parametric test. So this is a this Mann-Whitney U-test for two independent unpaired. This unpaired test now. The same thing we have unpaired test. We have the same here. These two data sets are unpaired. One numerical variable and one categorical for which is two independent sample. These two independent sample now. Independent independent sample. So the former one we did before pair are dependent sample. Don't forget that. So this one they are dependent because the same subject that was tested, I mean, was repeated twice, all right, same specimen. So it is dependent, all right. But this one, gender might be, for example, male and female, they are not dependent. So they are independent samples. So that's what it means. So you just have a categorical variable that are not dependent. All right, so the Mann-Whitney U-test is also called a two-sample Wilkinson test, right? This Mann-Whitney, because is also Mann-Whitney actually, okay? Just the term that I use, all right? So Mann-Whitney U-test is also called what? Two-sample Wilkinson test. Two samples, all right? I can call it two independent sample, okay? I prefer to use that language so that they can understand. Two independent sample t-test. All right. So this is equivalent to the independent two sample t-test we have done before. It is a test for differences between two unpaired samples or groups based on median. All right. Now, I gave some example the other time during the first one, and I'm going to repeat it again for sake of reminding us. For example, is there a difference between people who have a college degree and people who don't have in terms of their earth? Maybe you want to know based on their PB, want to know if there's a difference between the PB become the continuous variable, which is our numerical data now. Then college degree become the categorical variable. Okay, so the college they have, they don't have college degree, no college degree. So that will be two independent sample or groups now, right? So that's so. But now I want to use this PB as the numeric variable to check to test, all right? If there's a difference between those that have college degree and those who do not have, right? So that's exactly what you're talking about. So that is based on the median also because we are looking at a non-parametric test for Wilkinson, okay, or Mann-Whitney, okay. So now we want to also, so as for example, do two production lines produce screws with the same weight? So weight become the numerical variable. Then we have two production lines, which is a categorical variable now. So maybe line A, line B, right? That is a line A, line B, line A, line B, line A, line B, like that. Inside one categorical variable, then we now have their weight. For the line A, it has to weight, line B has to weight. So that is how you do it. Then you can now compare using media of this weight to see if they produce the same line of screw weight. So do smokers have a high risk of heart attack than non-smokers? So the risk of heart attack has a numeric value, okay? That will be your numerical data. Then you now have smokers, non-smokers, smokers, non-smokers. These are the categorical variable you have there. So you now have a column maybe called smoker. Maybe you now have a smoker, non-smoker, smoker. So that is just a categorical variable. Then you can now test using the risk, okay, which is the numerical data that you have there, find the median. Then also, is there any difference in the salary of men and women in a ABC company? Maybe your company, you want to know is there any difference in the salary of men and women? All right, salary become the numerical variable there, which you want to use to test, which is the mean. Then men and women become the categorical variable, right? And they are independent. The same way you have smoker, non-smoker here, they are independent. So, yeah, so you just have you can have a column called maybe gender, for example. There are men, women, all right. Then you have another column called salary. All right, so use salary as a categorical as a numerical variable, then use as a categorical variable. So you to test. So the data is very simple, as you can see, very easy to understand. That's why I repeated this again so that you can understand clearly. So you have if you want to generate this data like that, you can do it by yourself. I mean, generate for testing purpose. Unless now that you have understanding of how data look like, so that when you collect data, you not have any issue in handling them. So here we will use the sample data set which contains the weight of 60 individuals, 30 women, 30 men. All right. So the same way we generate the other time, we have to generate again. All right. So but this time I want to generate 60 observations. So let's just set a seed and generate. So let's run this. Now let's go ahead and also create the data frame. So we have a weight data. Now we call it weight data. Right. So if you run it, you have 60, both man and woman. Right. So gender is gender, either man or woman. All right. So now maybe question can come up. Maybe what we want to know. We want to know, for example, whether the median weight differ between gender. That's what I want to. So whether the median weight differ, or want to say, is there any significant difference between women and men weight, or between man and woman weight? So same. So want to know if there's any significant difference. Of course, we can check that first by using our usual method, maybe getting a plot, either box plot or whichever. So we can try to pass our weight data here, our gender as x-axis, then our weight y-axis, right? So we feed by gender to see the difference. All right, so we run this line of the code to see. All right, you can see here. So it's not the same, obviously. It's not the same. Even the mean is not the same. So the median is also not the same. All right, but we have to let's look at the group. Also look at the group the same way. So the group, just understand the concept of the group. Okay, passing the weight data set here. Our group data is passed. This is gender. Then we summarize. We count first. If you want to count, that one is not important, but we want to find the median weight. So median equals to median. We're passing the weight inside. You want to find the RQ interquartile range. You are also welcome. It's not important, but at least median, we need median. So let's run this and see. So we have gender here, man, woman. Okay, we have count 30 for each. Median is not the same. You can see 90.7, 60.0. You can see hierarchy is not the same. So you can see what I'm talking about. So looking at this data now, you can see that they have different weights. But is this different we are seeing is significant? Then we need to test. Maybe it's just by chance. All right. That is why we have to proceed and do the testing. So man weight is higher than that of woman, okay, but we want to know whether this difference is significant. All right, using the Mann-Whitney U-test, which is also called the two-sample recursion test. All right, so but we need to check the assumptions first. Okay, the data from each of the two groups follow normal distribution. I want to check, so we can use this individual group method I showed before. Okay, or you can use a combination of one. Okay, so let's use individual group first and see the result. Let's run this. This is highly significant, which failed the test. This is also highly significant, failed the test. Let's run this as well. This is also significant 0.01. This is a combination, which is also failed the test. They are less than 0.05, so they failed the test. So the null hypothesis of normalization is rejected. Okay, don't mind this. Okay, this is not correct. So we have it's rejected. We have a 0. Let's say we have 0.001, 0.018, 0.0188. That is our, so which is which is significant. Okay, so we can continue with our test, assuming with a test assuming assume no normality, right? So, all right, so that is that. So no normality is assumed here. All right, so we can continue our test using parametric method. So now we run our constant test. If you remember this, the same test we run the other time. All right, what change here? Exact. All right, so you can see this is Mann-Whitney. Okay, yes, this is Mann-Whitney U-test. It's also with constant test. It's same. In fact, if you check online, you see that they're the same. All right, so just passing your data here with, okay, your gender, which is a group, then data is equal to weight data, then now say exact equals to false. So that is the difference. So just run this now. Okay, run this. It's highly significant. Okay, so that means that we could report as that the p-value of the test is 0.0009, which is less than the signal level alpha 0.05. We can conclude that men's median weight is significantly different from women's median weight. All right, so that is that for that. So it's very easy to compare and contrast. So you just finish running this and you can see that both of them are accurate. So that is just about the Mann-Whitney U-test. So you can apply that on your data, on your experiment, which depend on your data set you are using. Thank you for listening for this section. I will source in the next section. So if you have not yet subscribed, you can go ahead and do that. Thank you.